Okay, so the first thing, you were all here yesterday when I was talking about the course, and you'll get a book for the course as well. I actually forgot to check if you have it in the office. So maybe next week I can give you the book for the course, but you'll have all the notes here. And also there's some notes on Moodle as well. Do you remember what Moodle is? Yeah? Moodle is, well, you know Moodle as well, Leo, don't you?
I can't remember.
Can't remember, okay. Okay. First thing to look at. Sometimes people have seen this before and sometimes not, but it's very useful. So you'll need to write these words down. First topic or first idea we're going to look at. Dimensional analysis. Has anybody heard this before? No, okay. Pretty simple enough ideas. For example, if I was to add x and y together, and let's say x represents something like a person's height. So what would you use to measure a person's height? What unit? Like maybe centimeters. Okay. I'm only allowed to add something that has centimeters to this, you know? So for example, if this is centimeters, then this one needs to be in centimeters as well. If I have x minus y, it's the same. Now what about x multiply y? Do they need to be the same units? No, they can be different units. Or the same goes for x divide y. So this one here, they need to be the same units. And this one here, they don't need to be the same. Okay? So same units here. This could be like centimeter, centimeter. But this could be like centimeter and kilogram. And this one here could be centimeter and kilogram. Okay, that's the first thing. So that's the first idea. Second idea, if I have something like this, an equation, A equals B, and let's say this one is in centimeters, then this one here, what do we think? Does it need to be centimeters or can it be different? It needs to be centimeters as well. So there's a symbol we can use. This symbol here, that's the, I suppose you could say the dimension or the type if you want an easier word. So for example, this could be like length, L for length, or it could be like M. What do you think M stands for? Mass. And then what do you think T would be? Time. So let's have a look at some examples of this symbol. So for example, height. What one is that? It's a length. It could be length, mass, or time. So which one is height? The length. And then what else could we do? How long the class is. That's a time one. But this symbol works pretty flexible as the symbol is. Like for example, if I want to know what the units of A are, that would equal the units of B multiplied by C. I'll give you an equation, which we'll do later, but I think everybody has seen it before. F equals ma. So you could say the units for F are the same as these dimensions, these units here. What units do we use for F? Do you remember? Newtons. Newtons. And what do we use for mass? Kilograms. And acceleration? Meter per second squared. So in fact, you're allowed to say that 1 Newton is the same as 1 kilogram meter per second squared. So you're allowed to change this. Now, where is this really useful? I'll tell you where this is really useful. When you have something like this, F equals G mm over r squared. Who knows what this equation is for? Yeah. What's it for? Gravity. Now, who knows what the unit for G is? Well, you might not remember it. That's okay, because if you don't remember it, you could do this little trick. You could rearrange it so you have f r squared over mm equals g. And the unit for g will be the same as this. The units for all of these. So what's the unit for f? Newton. This one? Meter squared. And the bottom? Kilogram squared. So I could say g equals 6.67 times 10 to the minus 11 Newton meter squared per kilogram squared. The reason I'm showing you this is it's important that you have units in your answer. And if you ever forget the unit of something, you might be able to use this to help you to remember what it is. Okay? So you all clear with that? Okay, so you do need to write this down too. So if you have pen and paper, yeah? So just write down a couple of the ideas that I've given you so you can remember it. So for example, the ideas are, firstly, this one here. Second idea is about this. And then I give you, we'll do this one as an example. So really all I need you to write down is the idea that for adding and subtraction they need to be the same unit, but multiplying and dividing they don't need to be the same unit. And then the other idea is this symbol, which means the unit or the dimension. And then this is the example. So really this is probably the most important one. So make sure you write this one down. How far? You want this one? The first. You're going to have to write quicker for me, okay? Okay. If you didn't write this down, you'll just have to get it later, okay? Like I said, I'll put this up on the internet, but it is a good idea to write as I'm writing. So, well, we're all going to be familiar with this, but I'll just, for revision, list all the types of units that we have. So the first one is for mass. What's that one? Kilograms. And then the next one we'll do is length. And what unit do we use for length? Meters. Then we have volume. And for me, volume you could use meter cubed, but you could also use liters as well, but I think I prefer meters cubed. Force, we know force is newtons, and then, wait, I know it's okay, don't worry. Temperature, Celsius. And what's the other one we could have used? Kelvin, yeah. No, not the American one. We'll stick to Celsius or Kelvin. And then time. Seconds. and energy joules and so on. When we study these topics, we'll introduce the symbols, but just for the beginning, these are the main ones. Okay. Now, you probably noticed this with kilogram. This K in here, what's special about this K? It means 1,000, yeah. So it means 1,000 grams. And likewise, when you're traveling, kilometer, 1,000 meters, and so on. So actually, you have a list of these. Does anybody know what these are called? Prefix. It changes the size. So K is 1,000. What about M, like millimeter? What does that mean? 1 over 1,000. Yes? How many millimeters in a meter? 1,000. How many centimeters? 100. 100. Okay, so I'll list all the ones that we'll use. So the first one, pico, that's 10 to the minus 12. And then the next one, more common I think, is nano, 10 to the minus 9. And then micro, 10 to the minus 6. And now we start getting into the sizes we're familiar with day-to-day life. Milli, that's 1,000, so that's 10 to the minus 3. Centi, that's 10 to the minus 2. Now this one, honestly, is not so common. I don't really see it so much. Deci, 10 to the minus 1. And then deca, that's 10 to the 1. So in fact, you could have something like decimeter. What do you think a decimeter is? How big is that? How big do you think a decimeter is? Don't know? Anyone want to try? How big is decimeter, do you think? If it's 10 to the minus 1. Yeah, it'd be 0.1 of a meter. How big is that? 10 centimeters. Yeah. And what about a decameter? How big is that? A decameter. Not 1 meter? No. Decameter? 10 meters. Okay. Now, hecto, 10 squared. So a hectometer would be 100 meters. And now kilo, 10 cubed. And I'll go back up now, don't worry. Next one, well actually maybe you know this from computers. You know you have byte, then you have kilobyte. What's after kilobyte? Megabyte. So the next one is mega. 10 to the 6. What's after mega? Gigabyte, yeah. And that's 10 to the 9. And then the biggest one, terabyte. And if you have an external hard drive, who has an external hard drive? Does anyone have one? You know what I mean by external? You plug it in, yeah. They're usually about 1 or 2 terabytes. 10 to the 12. Nobody has an external hard drive? At home, yeah. And how big is that one? Would it be more or less than a terabyte, do you think? More than a terabyte, okay. So some of these units you have in day-to-day life, and some of them are new. Pico, nano, and micro. Well, okay, the smallest one in day-to-day life is millimeter. These ones here, when do you start using these ones? Yeah, well, like what would you be doing if you're measuring something this big?
If like a cell or something like
Yeah, like a cell maybe, like in biology, yeah. Or maybe I'm just thinking like if you're making a computer, you know, if you're making really small parts, you might be talking about these sizes, you know. Okay. So maybe we'll practice just a couple of examples here. Let's see which one we do. What about maybe we'll do one like with a computer, like for example, if I had let's say 1 terabit, let's try and convert that into all our different sizes. So 1 terabit, how many gigabits is that? 1,000 gigabits.
So is it bit or byte?
Well, there's two. I'm going to use bit and byte are different. 8 bits equals 1 byte. But I'm just using bit in my example. But for your hard drive, it's probably in bytes. Okay. Right, that's a straightforward one. Let's look at another example. Let's say 3/4 of a meter. Let's convert that into millimeters. So 3/4 of a meter, that's 0.75 of a meter. That's 0.75. And now how big is a meter? What one we want? We want millimeter. How big is a millimeter? 1,000 of a meter. So if you go up here, you see milli is 10 to the minus 3. So this one here, what do I multiply this by then? 10 to the power of 3. Because if you think about it, you need to make it bigger. Because you're going to have lots of these little pieces. Okay. Millimeters. Okay, I think this one is straightforward. What I should do next with you is show you the symbol for each of these. So each of these has a symbol. Which one would you have seen before? Yeah, kilo. What's the symbol for kilo? K. And centimeter, like centimeter, centi? C. Yeah. Which other ones maybe? Millimeter, what do you think that one is? M. Yeah. Okay, so let's put them in. What do you think piku would be? Is that P? Yeah. Nano? N. Now you might know this one actually, micro. M-I. Good guess, not M-I. It's a Greek letter. No, Greek letter. Yeah.
It's a U. This U kind of.
This one?
Yeah.
What's this called? The name of this letter? Well, that's the name in physics, but what's the name of the letter? It might be the same in your native language. Because you know you have alpha, beta, gamma.
Yes. Yeah.
What's this one called? Oh, come on. What is it? Mu. Mu. Yes? You know Mew? Like the Pokemon? Yes? You know? You all know Pokemon? You know Mew? MU is how you the word pronounce it like this. Okay. Hmm? Huh? Like which one?
The sound of a cat.
Oh yeah, but that one too, yeah. Okay. Deca, D. And then deca is DA. Hecto is H, so that's not really surprising. Mega. Now, if we think to megabyte, gigabyte, and all this stuff, what's mega? It's M, but it's a capital M. That's the difference between milli and mega. Giga, capital G. And then tera, capital T. So some of these are in day-to-day life, some of them are new for you, some of them you've seen before. Okay, let's see. I don't think there's too much more now to do. Just some vocabulary. Just to make it clear, because I didn't make it too clear just yet. Units are things like meter, kilogram, centimeter, whatever. Dimension, that's the name of this lesson, dimensional analysis. Dimension, that's things like mass, length, time. So there is a small difference between the two. It's not really big, but time is a dimension and seconds are a unit. So there is a difference between the two, okay? But really it's not so important for us. But it is good to know the difference in the words, okay? So if I said, let me think, like here, there you go. This is measuring time. So it's measuring time, which is a dimension. But what is the unit here?
Second.
Unit second. But what's the unit on this one? Hours. And this one, minutes. But they're all the same dimension, time. So it's good, you know, for physics, like with chemistry and biology, you have to learn these words, okay? So dimension and units are two important words for this lesson. Very important words. Okay, let's have a look at some of your worksheet questions. Okay, so I have some questions here for you to do. So just to help you out, I'll do a couple as an example for you just to get started, okay? And then I'll give you the worksheet. Can I go to a new page here? Yeah, did you write these units, and did you write the other word down here? Dimensional, dimension.
No, I didn't write.
Okay. You got it? Yeah. Okay. So you have units, and you also have dimension. Okay. Right, let's have a look at some examples. So I'll do number 1 for you on your worksheet. So question is, how many milligrams, yes, so he says, are in 1 gram. So you don't really need to work it out. Yeah, it's 1,000. Okay, and then I'll do question 1 on the second half of the worksheet. And the question is, are you allowed to combine these or not? So for example, 5 inches multiply, you all know inch?
Yes.
It's not so common here, it's more a British and American measurement. What's an inch? An inch is about this big. If you didn't know it, an inch is 2.5 centimeters, about. We don't use inch here, they use it in America. 5 inches multiply 4 inches. What's that answer going to be? Firstly, are you allowed to do this? You are.
Yes.
What's the answer going to be? 20 inches? Not 20 inches, 20 inches squared. Yeah, just like here. Maybe this is 10 centimeters, and maybe this is 20 centimeters, and when you multiply them, what do you get? 200 centimeters squared. So this first exercise is all about practicing your units, being careful with your units. So I'll give you the worksheet. I think you can do them. Well, I hope you can do them.